Hello, welcome to another episode of Xa Talk Show. So today we are going to do very fun stuff. Okay, so we are going to code Emacs Lisp, Python, JavaScript, Golang, and Wolfram Language. We are going to code a find and replace program. Okay, so given a directory, 1,000 files. We're going to test on 2,000 files also. Let's say 1,000 files and do find replace. So multiple pairs of find replace. So you want to find, for example, all the word Lisp to something else, to Python, find replace. Okay, so we're going to write a script in all these languages, do find replace, and we are going to compare their speed. Okay, now I suspect Golang will be the fastest. The second fastest will maybe Emacs Lisp. That's what I suspect. Emacs Lisp for find and replace will be faster than Python, JavaScript, and Wolfram Language. Okay, and Go might be faster. Okay, so that's what we are going to do. Okay, so this is gonna be fun. It's probably gonna be more than 1 hour, 90 minutes maybe. So let's begin and let's try to do it fast. Okay. Okay, let me focus. Let's do this because I wanted to do this for a long time. Find replace which language is the best. Now Wolfram Language is probably the easiest. Okay, once you know Wolfram Language. But the most flexible and powerful and easy to code, the most flexible and powerful for text processing would be Emacs Lisp. Okay, and Go language here will be the most cumbersome because you have to convert string type to a slice of what they call run. Okay, to a slice of run data type, which basically means Unicode characters. So that means basically an array where each element is a Unicode character. So you have to convert a string to that data type. And the reason for that is that string in Golang is just a sequence of bytes and immutable. But because you are doing find replace, so you need them to be mutable because otherwise it's going to be extremely slow. Every time you do a find and replace, it's going to recreate the entire string. So you don't want that. You want to convert, in Golang, you want to convert the string into an array of characters, Unicode characters. So, and in UTF-8. And so it's going to be for each character, it may be 1 byte or 4 bytes. So it's the most tedious. Okay, Golang. Let's hope we can finish this. Okay, if you have comments and questions, post it. Okay, be relevant, and also if you are watching offline, you might want to play at double speed or something. So because this is gonna be a long one. So find replace. So first of all, let's go to the text, the directory we want to find. So we are going to use Emacs Lisp manual. So Emacs Lisp manual, you just go search online, you'll find it in a downloadable zip file version. Okay, so it's gonna be 1,000 pages. Emacs Lisp. So let's copy the directory here. Okay, so let's, I hope to do this quickly. We can time them and compare the speed. Okay, so first, and when you do, now one of the things critical in this speed comparison is that find and replace, not just find, not just grab. Because if you just want to do grab, there is no mutability involved. You don't need to change anything. In that case, the fastest is called silver something. There's several new grep utilities like Unix grep. Okay, so let me find my so I'm just going to go slowly, leisurely. Okay, so grep, let's search for grep, rip grep. Okay, rip grep is the fastest. So I have several articles you can learn about rip grep. Rip grep has a fatal flaw. That is, this guy refused to make his program into a find and replace. He just want to search. He don't want to, because he think, according to him, he says that it's too complex to do it right. I think he's just chickening out. Andrew Gallen, a great programmer, but he's chickening out on a task with some kind of obsession, with some kind of excuse, saying that, oh, once you want to do, find and replace, then it's gonna be too big a problem, too big a project, too big a complexity to make it right. So I think he's chickening out. But in terms of, if all you need to do is just find, then ripgrep is the fastest. Okay, there are also several others in the past 10 years, Arc, Silver, and so on. So actually, we did. I looked into ripgrep in depth, and I think I also did a video on that. Anyway, find replace is my thing, because that's because my website, 7,000 HTML pages, all manually written, like you see every day when I'm doing live stream. So since they are directly in HTML, so I have to, for example, this topic box, that topic box exists on every page, and for example, let's open another page. Okay, so for example, let's randomly open this one. What is this? Oh, text file. Okay, so HTML. So you see, this panel, navigation panel, exists on every page, so when I want to change something in the navigation panel, I have to do find and replace on 1,000 pages, or usually a few hundred pages. So that is why find replace is critical for my system, for my web dev system. You might be thinking, so why don't you use some kind of JavaScript or variable? I tried them all. They are no good. You want them to be static, so you want them to be, you can base it on template. If you base it on template, some of you use org-mod, some of you use the Hide, Jackal, and whatever. They are two very popular. If you want a static website, if you use a static website generator, then your source code is gonna be some kind of markup or markdown, like org-mod. You can also use markdown, Then you have to generate the page. So the page is gonna be very easy to read, without all these tags. But however, every time you have the extra step of generating the page, and you also have other complexities. For example, you have quite a few complexities, because then your template is not as powerful and flexible as compared to raw HTML, because raw HTML and CSS, you can control it in any way you want. For example, here's my CSS file. I can reformat them, I can control them, But if you based on template system, every time you want a new tag or something, you have to kind of create a new template for that. Anyway, so the point is that when you use a static website generator, so-called, used to be called content management, okay, website content management manager. There are like so many in the past 20 years, they come and go, and each generation just knew a few. So today, the most popular is, let me try to find it, static website. Okay, at this rate, we're gonna, this is gonna be like 2 hours. Okay, so let's see, these are all crap, these are all ad field spam website. They pounce on the most common questions, or each one of these idiots. They are not really there to answer your question. They are there to, they are usually hired cheap writers by commercial entities or spammers, so that their results, they have search engine SEO and whatever, they have a team doing that. So their result come up on top, and typically their answer is the most worthless shit. What is a static site generator? Cloudflare. Oh, Cloudflare also doing that. Okay, so let's look at a few. Okay, typically this website, using the latest framework, they think they look pretty, and they usually have a spammy, irrelevant, image, so that for people who don't know anything about anything, they can say, computers, static website generator, But if you just want quick answers, usually they tell you, okay, so what is a static website generator in 2023? Oh, they are quick to change the date. Look. For SEO. Okay, so there are a few. Okay, so yeah, usually they are filled with spam or, and built-in SEO functionality. What a crap. Static website versus dynamic site. So where are they? Jaico, okay. That's one of the most popular, okay. Let's copy it. So that's one of the most popular, and there's another one. Jaico is one of the popular, and what is the these like content management systems, okay? That's what it used to be called in 2000s. What's a Jamstack? I have no idea. Okay, Markdown. Okay, Jaico, and another one I heard of, all the geeks, all the nerds telling me, why don't you use Hugo? Idiotic, okay? I would claim my system is faster when you want to write anything, any page. It's faster than them. It's more flexible and more powerful. What I mean by faster, meaning less number of keystrokes. Writing the same page in my system, you need less number of keystrokes. For example, all the H3, H1, I can, for example, something, okay? 1, 2, 3, 4. 4 key presses gets you that. And if you want that to change that to H2, 1, 2, 3, 3 key presses. And you can see the command, you see there. So the cost of using XR system is that you really have to know the in-depth all the HTML, and all the CSS, and you have to also be a master of Emacs, and you have to also have, I'm using XR HTML mod. So you have to, learn all this stuff. That is the cost, just like Emacs. For a typical programmer, you can use VS Code. You can start to code right away. But if you want the utmost efficiency, Emacs or Vim is better. However, you have to spend 1 year to master it first. So that's the trade-off. In a similar way, the way, I create, 7,000 HTML pages on xali.info and xali.org over the past 25 years, since 1997. That's my first web page. And xali.org started in year 2000, exactly. So they are written in Microsoft Word, character by character, tag by tag. Of course, I also mastered Microsoft Word, so I have lots of macros, but in Microsoft Word, that's the beginning, 1997, okay. But by 1999, I started to use Emacs exclusively for all text editing. So after 20 years, I started to learn Emacs Lisp in 2006. So now I have a system, a complete system. So, and, that's why I would say it's faster, more efficient, more powerful, more flexible than any of these Jaiko or Hugo. Okay, that's a giant digression, but let's start it to code this today. Okay, so let me just mention Jaiko and Hugo. Okay, here. Okay, turn off these garbage websites, spam websites. Okay, now so first step is to so we want to do the find replace on this directory. So we need to let's see, no, copy paste new blog. When will you be on Lex Friedman's podcast? Lex Friedman. Lex Friedman is a phony. You know, the classic jargon for Lex Friedman is phony or careerist, opportunist. That's what Lex Friedman, fake, you know. He pretend, you know, he always say nice things like the Dalai Lama, you know. Oh, humanity, we must be the most peaceful. The love is the key to the whole humanity, you know. A quip like that, Lex Friedman, but phony. You know, he's there. Whatever he do is he's got one goal, so that he became more popular and more makes more money. That's the only thing he interested in. You know. Anyway, so but today the Malaysian Zoomer jargon for that is squifter. Okay. Okay, so yeah, let's focus on this. Okay, yeah, this is gonna be a big task, and I already talked for 20 minutes. So here is milk and banana. Lex Friedman, you know, you know, watching his video, the way watching him, the facial expression, the way he talks. The style is offensive, deeply offensive. You know, a bunch of fake things, and he doesn't. You know, he's an idiot. He's got low IQ. He doesn't know what he's talking about. You know, and this, and the most critical. I mean, the most important is the fake, phony. He's got only one goal: to make himself popular, more money. That's what he is. And here's coffee and milk. So let's focus. Let's get back to this. So we are going to write a find replace script in multiple languages, and first of all, we need to prepare a directory for this find replace. Okay, so let's prepare a directory. Okay, so let's just go to, so close that. Okay, so let's go in here. Let's create a directory XX. Let's just name it that. Okay, and we want to copy the entire Emacs Lisp manual to this directory. We need to do this multiple times. Even yeah. So okay. So for example, I want to copy this file path. Okay. So you know that's how it's done. And let's just use. Okay. Let's hit PowerShell. Okay. So PowerShell superior than Bash, than the 30 years Unix Bash baggage. Okay, that's the syntax recursive actually. Recursive, okay. Copy recurse one directory to a destination, okay. So, and what's the current directory here? Okay, so, and let's replace that by okay, let's see. So let's do PowerShell. So we got a PowerShell, okay, and copy CP is alias to copy item. So you can either use CP. So let's try it, okay. Cancel, paste. Oh yeah, so we missed this part needs to be a directory. Okay, copy, cancel, paste, do it. Okay, done. Pop it back, drop into the directory, open that, refresh, there it is, Emacs Lisp, okay. So copy that directory, close, close, close. Okay, so here is the directory we want to work on. Okay, so we're gonna write, so first of all, let's write a Emacs Lisp. Okay, so because my audience is mostly Emacs users, and they trust, you guys trust me on my Emacs Lisp. Okay, so let me show you how it is done. I have it already written. For example, let me show you, and let's just do it. Okay, so for example, let's open that. Let's say I want to change all words files. Okay, you see that word files? I want to change them all to, let's magnify a little bit. You see the word files. Okay, so I just call this command. Press. Let's show the pink window. Okay, watch the pink window. You can see the command name. Do it. You see, find replace text. Okay, paste files. I want to replace that string by what you want to replace by. Let's say something random. That. Okay. Enter, and which directory? This directory. Enter. What HTML? I mean, what pattern for the file? Regular expression. .html. Okay. Minimum the depth, okay, starting at 0, okay, maximum the depth. So this is a nice feature to have, so you can specify a range of directory depth, because this is important if you want to do find and replace in HTML. Sometimes you want to focus on a specific directory level depth, because otherwise your relative links will all be wrong. Okay, so anyway, so max the depth 99, write changes to file, let's say yes, fixed case in search, yes, fixed case in replacement, yes, backup, make a backup, yes. Okay, it's going. There it is. Okay, so there are 10,000 files, so you can scroll, you can press the arrow key, and you can open the file. So you can see this word has changed from file to that, you see. So this command I'm calling, it's this one, find replace text, and it's in the package find. Okay, if you want it, it's open source, but you have to pay. Okay, support me, because I've been doing open source for 15 years, and nobody gives a shit. But instead, you become tech support. You spend 1 hour every day to ask people's questions, to answer people's questions. So this command is already there, and there's also a regular expression version, and so here is a source code. Go to the top, and you can go to this home page. So if you like it, support me, go there, pay it, I'll send it to you. Okay, so this is one of the most useful, and the code is 700 lines. Okay, close. Okay, so we demonstrated find and replace of this package find, which includes a nice user interface. You can jump to it, things like that. By the way, of course, if you are an Emacs user, Emacs also have that feature, but it's not as good. I mean, that's why after several years, eventually I developed my own package. Emacs, also has that. Okay. So we have done that, and now refresh the directory. You can see all the backup. It automatically makes a backup. Oh, so that word does not appear in every file. So you see, only some of them's got backup. So okay, copy the directory, close. We also want the command to delete that directory. Okay, so let's add here PowerShell RM is a short name, alias for remove items. So we can do recurse again. Okay, let's see. Let's open it. So it's a directory. Close it and run this PowerShell command. Okay, instantaneous. Let's look at open. It's not even there. So open. You see, it removed them. Okay, that's good. Let's just say RM. Okay, so that way it's more familiar to the Unix heads. Okay, so we got the script to remove and copy. Yeah, so and now we need to do copy again. So this is gonna take a long time to code this. Okay, so now let's try to open it. Okay, fantastic. They are all pristine now. Now, let me write a script to do find replace in Emacs. Okay, so let me show you how to do that. So Emacs Lisp. Of all files in a directory. Okay, that's our documentation. How do we want to do this? Let's do this in not as a function, but just as a script, so that we can run it in shell. Okay. So, and for these purposes, let's hard code the directory path, because we are trying to test the speed. What is this? Oh, this is today's talk show. What? Wait, we screwed up something. Wait, 2000. Yeah, this is today's talk show. So where did we put that? Oh, we put Emacs blog, wrong place. Okay. Copy. We can select, progressively select more stuff. Show in browser. Yeah, we didn't screw up my Emacs blog. Okay, close. Now paste them here. Okay, don't need that. Show in browser. Fantastic. So here we got our PowerShell. Now, next step is to so let's see. So remember, we need the directory. So let's copy that. Input okay, so this is Emacs. You don't have the equal sign. You use setq to set the input directory, and the input directory is going to be that. Okay, so for now, the next thing to do is for each file, we open them. Okay. And what's the best way to, so you need to traverse a directory. So what is the best way? Look up Emacs Lisp basics. So now you go to practical Emacs Lisp, and file and buffer section, you have walk directory. Okay, let's see which one we want to use. Directory files, return a list of names of files in directory. And then we also have list directory and all subdir. Okay, and we have a custom function to filter directory by depth level. Okay. In this case, we just need the flat, okay, directory files. That's all we need. Close that. Okay, so we need to do something like that. Okay. Directory files, input directory, optional. So let's look at describe function. Let's look at the documentation. Full, match, no sort, count. Okay, return a list of names, 4 optional arguments. Full is the nil, return the absolute file name. Yes, we want the absolute file name. Okay, true. If match is the nil, mention only file names whose non-directory part. Okay, that's basically filtered by the file name. Okay, we don't care. Match is the nil. Okay, so we have nil. And no sort is useful if you plan to sort the result yourself. Okay, no sort is true. Okay, there is a new option. It's missing in my Emacs tutorial. A new option, count. If count is the nil and the natural number, the function will return count number file names. Okay, we don't care. Okay, so anything else? Has anyone ever tried applying softfly keys in Vim? There is someone wrote a Vim package 7 years ago, 7 or even 10 years ago. You can find it. In fact, I have a link in my website. Someone wrote a Vim package that emulates the keystrokes in Ergo Emacs. Okay, Ergo Emacs is a Emacs package that's the precedent. That's the previous version of. That's the beginning. That's before softfly keys. Okay, but it's not modal. So, but the key choices are the mapping to commands are similar. So Ergo Emacs. Then I created XAR Emacs, and someone wrote a Vim package based on Ergo Emacs keys. So, but actually, I've been thinking of creating a softfly keys in Vim and in VS Code, in particular VS Code. So the idea is that because softfly keys is that's my original vision, because it's a editing key map system that is not just useful in Emacs, but can be in any editor or IDE, VS Code, Vim, in Wolfram Language. So that was my original vision. I just never get to do it. It takes time. So, yeah, you can do it yourself, but there are quite a few people trying to do that. That's the nature of Emacs user. Like and hackers and like someone create a package, and you think it's good, but you don't want to use it because you want to add your own touch that becomes your own. Then you can say this is mine. Like people have been using the meal or something. They're trying to then they copy my design, which is a bit annoying because well, that's the nature of open source. Because if I have the power, I would patent it, just like Apple, Microsoft. That's the actual way to get it to grow to have money so I don't die, and also to expand it to the world. Because open source is just crap. So directory files input. Okay, so now file list equals to that. Okay, in fact we can run this. Okay, run, show the pink window, run. Oh, something is wrong, just 2 files. What is the, wait, why is it just 2 files? Oh, that's right. Yeah, actually the directory you want is elisp. Okay, run it. There it is, 1,000 files. Okay, now you have a list of files. Now you want to open each one. So how do you do that? You can do it by, there are many ways, but you have to be careful, because Emacs, you don't want syntax coloring. Every time you open a file, Emacs calls the major mod and do all the syntax coloring. That's very slow. So if you are writing script, you don't want to call find file. Okay, you want to do something else. And here is a tip to how to do that. Open file. So let's see. Read file. There it is. Okay, and actually we also need write file. Okay, so let's look at read file. So this is a great idiom to quickly, if you want to write a script to process files, this is the way. You don't want to call find file. Then it invokes syntax coloring. It also invokes undo, recording, undo, and redo. So every time you do something, Emacs record and undo in the background, super, and slows you down tremendously, and by 5 times at least. Okay, and also every time you open file, then one bunch of hooks gets called, because, for example, the highlight current line, that will also happen if you use find file, because Emacs is just like real interactive. So you don't want that. So you want to do it this way. Okay. So this is a function, where you just basically, all you want to do is create a temp buffer, then insert the file content by the path. Okay, this is the best idiom to open file and do something. Okay, do something. Okay, so open the file, do something. So here is the find replace you want to do. Then you want to apply this function to this bunch of files. Okay, so what you want to do is you say mapcar, and the function name will be just that. Okay, my process file, and the sequence will be xfile list. Okay, so we use mapc because you don't care about the output. Otherwise, so mapc is like JavaScript's for each. Okay, if you want the output, then you have to say mapcar. Okay, let's magnify. Okay, so but now we're gonna focus on this process file. Okay, so once you insert the contents into a temp buffer, then you want to go to char point minimum. Okay, go to char 1, point minimum is 1. Okay, what? Okay, you go to the beginning and okay, let's think about what text we want to find and replace. It needs to be, we are going to make this decision for also the code in Golang, in JavaScript, in Python, So let's write out text that pairs that we want to do find and replace. Okay, let's say, okay, so let's say something to something else. Okay, and what are those something? Let's go look at the Emacs manual. Let's see what kind of things we want. Okay, so this word happens in every okay, let's say previous to p something. Okay, so let's find some other word. So there's a word lambda that also happens frequently. Let's say we want it to be let's just say random character for now. Okay, then yeah, we want to do multiple pairs. That's important. Let's see, right? Okay, let's say 2. Let's say that. Okay, that's a very common word. That to that. Okay, let's make this okay. Suppose that's what we want to replace. Find replace pairs. Let's do one more. Okay, function. Okay, function is a frequently used word. Yeah, wait, let's try something else. Let's say number. Okay, okay, so let's say these are the find replace pairs. Okay, and showing browser. Okay, okay, so yeah, let's copy that. Yeah, let's do it. Okay, let's go back to the Emacs Lisp code. Okay, so now we have a bunch of find replace pairs, those. Okay, what to do? Here's what to do. Go to char 1 while, and do we want to use regular expression or not? Let's see. Let's say no. Okay, because I want to test find replace, focusing on the speed of find and replace. So I don't want to use regular expression, because if we use regular expression, then that will involve the speed of regular expression in different languages. In Golang, in JavaScript, in WolframLang, each language's regular expression will have a different performance characteristics. But for our purpose, I just want to see the speed of find and replace, because if we focus on that, I believe Emacs Lisp will be possibly faster than all these. Okay, maybe except Go. Okay, so we don't want regular expression. So we are going to hard code. We are going to hard code these find replace pairs. Okay. Okay. The first pair is search for word that optional bound nil no error. Bound nil no error true count we don't care. Replace match. Okay. Replace match by that. Okay, fixed case, yes, literal, yes, string, nil, sub-expression, we don't care. Okay, now this is how you do find replace. Okay, so you have multiple pairs. Now all you have to do is just let's make it 4 copies. Okay, and here will be that. Okay, so let's do this. That lambda becomes that. Okay, and num becomes that. Okay, so here is our complete code. This script will do find replace. Are you sure? Yes, I'm certain. Oh, that's right. Are you sure this is correct? Yes, I'm certain this is correct. Okay, so now pop this back. Search failed. Oh shit. Yeah, we moved it. Okay, so cut, close, and paste the code here. Okay, syntax correct, show in browser. So here is the Emacs Lisp code. And now we need to put this code into a script so that we can run it on the terminal, and we can call PowerShell measure to measure the time it takes. So let's do that. So we need to prepare, we need to create several yeah, okay, let's do that. Okay, let's go to the directory, go up one directory. So we're gonna have several files here. New file, this is Emacs Lisp. Okay, so there is a Emacs Lisp version, find replace. Okay, let's double check. Okay, so I think it will work. Okay. Oh God, I'm getting tired. Expose, yes, expose is the keyboard. Hello, change through. Okay, so let's open a PowerShell. Now, PowerShell. The power of shell, PowerShell. Okay, so we can run. Now, what is the syntax? Let's see. Where is my Emacs? Okay, Emacs 28. Fantastic. Okay, so I can just run Emacs, and what is the, I believe it's script. Okay, I believe that's that. Okay, but let's double check. I need to double check. So go back to Emacs tutorial. Hold on a second. Let's go back to talk show, because I want to keep the links we talked about. Copy, paste, close, copy. Oh wait, we forgot to write file. Oh yeah, so we forgot to write file. So yeah, we didn't write file. So correction, okay, open it again. We forgot to write file. Okay, so open it, go here. Here's the directory. Here's a find replace. Copy the file path. Close, 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 and put it here. Okay. That's Emacs Lisp find and replace. Okay, we need to modify it because make a backup because we forgot to write file. Okay, once you made all this find replace, let's make it one line. Okay. Yeah. Okay, so so now you need to write to file. Okay, so what do you do? Write region. That's right. And no backup. That's right. So we want to write to file only if some replacement happened. Okay, we don't want to write to file when there is no replacement because that way it'll be inefficient. Okay, so so which way to do it is the best way? My back, oh god, I need to walk for 10 minutes, for 5 minutes. Open read, possibly right. Okay, here is an idiom I have already. Yeah, so when file changed p, so you just set that. So when file changed p, how do you, yeah. Okay, so we need the let. Okay, neo. How do I do this efficiently? Because we can say that, you know, set it to true. But however, if you do this every time it find a new occurrence, you'll set the variable, so it's redundant. So how do you do that? Oh god, this is gonna be 2 hours, and I don't think we can do all these languages. You know, we're gonna do several languages. Okay, anyway, let's just go slowly, my usual phase. Okay, so you want to So there's a variable in Emacs called buffer modified. Okay, there's a function that returns true if the buffer is modified. You see, since its file was last read or saved, so this does not apply because our buffer is a temp buffer. It's not associated with the file. So this does not apply, this buffer modified. Okay, so yeah, let's look at the buffer functions. This is a new feature in Emacs 28, by the way, which is fantastic. It lets you easily see all the functions related to some topic. Buffer live p. Okay, buffer name window buffer. Okay, I don't think there is a function that buffer size. No. Okay, so no. So how we want to do this? So we cannot use buffer modified. Okay. So God. You know, one way. So if you are doing this, another way, you know, one way to do this is that like this. Let me show you, okay? So one way is that you go to char, you search for word, then if search for word is true, then that means you found it. Then you do the replace match, then you set the changed to p. Okay, so and we can change this if to when. Okay, so once you do that, one step, then you do this. Then you do a while loop on the same thing. And now this time you don't need to do that. Okay, so this is one step. But then you're gonna repeat it for 1, 2, 3, you know, for each one of them. So that certainly works. Okay, so this works. But, so this time you don't have to go to char. You just say that. Yeah, but it's more code. So is okay, so if we are going to do this, then we are going to copy this code, replace each one of these find replace by this more verbose code. So which does the job, but you have lots of repeated text, like right now. So another way, so to make this condense the code, you can turn this bunch of find and replace pairs into a list. Then you just map over the list. Painful. Okay, let's really think about for each one of these. So previous, yeah, so you either do that, you know, that versus that. Anyone watching? How many people? Fuck. Oh, 8 people. I'm popular. So anyone, any comments? Oh God, I need to take a break. Okay, let's just I suppose let's just go through the painful way. Let's get this to finish. Okay, double check one more time. Okay, go to char, then find when this happens, you do the replace and you set the change to true. Then you do a while loop. Okay, yeah, that should work. But before we do anything, let's just write the file now. Okay, let's just write the file. So write the file. Okay, so when file changed, if the file changed, write region. Okay, write region point min point max. File name is gonna be fpath, and optional append no, visit no, log name no, must be new no. I don't know what that is. Must be new. Let's look up describe function. Must be new. If must be new is neither nil or Excel, that means ask for confirmation. Okay, we don't care. Okay, so let's just do this for now. Okay. And it's these are formatting issues. Okay. Make a backup. Okay, that's it. Now that is the Emacs Lisp find replace file. Close it, close it. Now what we need to do is to find out how do you code a script, Emacs script. What is the syntax? Okay, where is it? Here. So so you go here, run Emacs scripts. Repetitive strain injury right here. It hurts right now. Typing too much. Okay, so here is how you run it exactly. Dash dash script 2 dash, the GNU convention. Script run Emacs like batch with load set to path. Okay, yeah. Okay, so let's run that. Do it. Oh, it actually prints the output. What the fuck? Suppose it worked. Okay. File error. What? Debugger entered Lisp error, file error, opening input file, permission denied. Oh, did we get what? Insert file contents, file error. Enter Lisp error, debugger entered Lisp error, file error, opening input file, permission denied, and C users sorry info Emacs. Oh, we got the input directory incorrect. Yeah, shit. That's. Oh. Shit. Did we screw up our code? Yes, we did. It shouldn't be in the should not be in this directory. Shit. This is my Emacs directory. It should be in talk show. Jesus. Okay. Emergency fix. Okay. Did I screw up my Emacs? Okay, Emacs manual. Did I screw up here? No. Okay, good. Now let's open that. Search for XX. Open that. Okay. Copy that. New frame. New buffer. Save it. Paste it. Okay, this is critical. You don't want to lose that. Then all these directories delete. Okay, that's right. All these directories go up, delete the entire XX. Let's double check. We don't want to make any errors here. Okay, delete XX, yes or no? Yes. Recursive, yes. Permission denied because probably because on Windows, you have to close, you see, that's why. Yeah, fucking idiotic. On Windows, you have to close all the open file thing. Okay, refresh, delete, yes, deletion done. Okay, now let's clean up our error here. Now this path is wrong, close that. Okay, info, okay, close that. Now, we got our directories wrong, so go to talk show, search for XX, no, doesn't exist. Make a new directory, plus XX, okay, refresh, open it, empty, that's good. Copy the file path, close. So this is the file path it should be. Okay, so go to it, copy the Emacs Lisp code, new buffer, paste, save it, xelisp.el. Okay, drop to the directory, there it is. Make a backup, open, double check, correct. Okay, close. Okay, now let's be very careful here. Open, copy the file path, close. So the Lisp file is here. Okay, delete that. And we need to fix our PowerShell. Okay, so yeah, that's not the right directory. So yeah, we got it wrong here. So the directory should be that. Okay, not that. Okay, and the remove recurse. Okay, hold on a second, open it. Okay, so it should be elisp. You gotta be very careful here. So this removes the elisp directory, which doesn't exist now, and here we copy it. Okay, so let's copy it. Go to the directory, oh, not here, so open it. Okay, now paste, copy all the Emacs Lisp manual to there. Okay, done. refresh, there it is. Open it, yeah. Okay, close it, copy the file path, open it, yeah, close, okay, pop it back. Now let's fix some of these. Don't need that. Don't need that. Now that we need showing browser. Okay. Yeah. So now actually so now we do the we run the Emacs Lisp code script. Okay, so check, yeah. Okay, now we need to get the path correct. Okay, open the Emacs Lisp script, get the path correct. So the path will be that. Okay, so let's right. That's right, input directory. Okay. Okay, that is the file. Okay, now open a new PowerShell. There it is. Let's double check. Yeah. Double check our code. Yeah. Comments? Any comments? Okay, let's run it. Do it. Oh, I hope it's not error. Fuck, debugger error. Opening input file permission denied. XR web, XR Emacs info talk show XX. Why permission denied? Oh, and we forgot, and okay, that's one error. We also forgot one thing, because you see, now it's trying to insert file contents of this path, and this path is ... That means go up one directory. Fucking idiotic. So we need to fix this file list, directory files. We needed to say match, okay, because we don't want the Unix ... The fucking Unix, fuck. You know, that's one of the damage of Unix to the computing industry. Because you see, let me explain if you don't get it yet. Directory files, given a file path, it should list all files in that directory, right? But however, in the Emacs Lisp case, it also returns ... The fuck Unix, fuck the Unix, fuckheads. Why should it return ... So I mean, so this essentially, this like typically you don't want. Hello, Gayash, thank you. So let me read the comments in a bit. Okay, so that's a problem. Okay, so the Unix, this is a Unix damage to the computing industry. So in this case, to fix it, we want matches the neo mention only file names whose non-directory part matches the rejects. Okay, So this part will be a rejects HTML. Let's just say that should work. Okay, so that fixed this part, but however there's still debugger entered, file error, opening input file, permission denied. What do you mean permission denied? I can't see why is permission denied. So let's see the comments. Your command saw open file at cursor has saved me a lot of key codes. Thank you. It's banana and milk. I don't understand why the permission denied. Oh, you see, maybe it's because of these. Yeah, because of the dot dot. That is why. But because of the dot dot, it's trying to go up one directory. That is why it's trying to do something to the XX path. It's trying to do something to this directory. But even that, I don't understand why is it permission denied, because this directory is still anyway. Let's run it again. You should work. Let's copy the eList file in case it overrides it. Okay, run it. Fantastic. Now refresh. Let's open eList file. Let's check. Let's open. You see, it worked. You see, there it is. One replacement. And what's the other? So that underscore list matching lines, there it is. Great, it worked. Then there is that list matching lines, one occurrence, and there is that number num underscore. So it didn't wait. So it didn't happen in this file. Okay, so it worked. Okay, our Emacs Lisp script works. Now we just have to time it. Let's try it. There's a problem because right now we can just time it. Let me show you. But this time is fake because you already did the replacement. So when you run the script again, it doesn't actually do any find replace. So that's why you have to close showing browser. That is why you have to run this PowerShell script. Let's do it. Let's run them separately. Do it? Yeah, what happened? God. Do it? Okay. Do it. Okay. Now if you open that, drop to the directory, open that. Now look Now you see they are back to their original. Okay. Now we can try to run the let's run them in the same window. Okay, so close that. So we want to run this script. So this will be full path. Okay. That. And in fact, it's dangerous to have the script here. So I don't want the script in the XX directory. I want to move up one directory. So let's do split, go up one directory, go here, capital R to move. Yes. Okay, so we move that file there. Okay, now it's good. Now make a backup. Okay, so we got the file there. Open it. This is still good. Close. Close. Refresh. Close. Close. Now that should be that. Okay. Copy it. Paste. Do it. Why is it the measure, does it measure time? I mean, why is it 0? God. Okay, let's close that. So now you can see we have a bunch of PowerShell scripts to do our stuff. But the measure command is returning 0 because, oh, measure time, that's right. And, you know, so I forgot what's the PowerShell command. So let's go to PowerShell. I have a tutorial. Check out my tutorial. Okay, so it's good. So how do you test speed of things? Let's search for speed. Okay. I believe there's a measure time. So new tab, help, measure, measure command. Yeah. So what you want is the measure command. Okay, measure command, measure the time it takes to run script blocks in commands. Okay. Yep. How do you God. Fuck, I didn't prepare this. So let's see if I have an example how to use this. Search for measure command, this directory, HTML, fixed case in search, no. Okay, that's not there. Let's go to do and search that directory, HTML, fixed case, no, print surrounding text, yes. So yeah, so here is the PowerShell. In one of my to-do, the documentation measure command. So example, so okay, so you have to do it that way. Okay. Okay, so I think no, close PowerShell. So we need to do measure. So the command is actually something like that. Okay, let's try it. There it is. Milliseconds. Total days. Jesus. Total milliseconds. Okay. 291. Now if you run it twice, it's gonna be much faster because it will load all the files in memory. 270. Let's do it. Big bird 280. Okay. 300. Okay. Let's do it again. 279. Okay. But if we run a command to remove the directory, now you see, now we remove the directory and we copy the whole over. Okay, now we actually do the find replace fresh. Now it will actually find those string and replace, do it. So it takes a while now because it needs to write the file, you see. 4,000 milliseconds. So this is milli. 5 seconds basically. Total seconds, yeah. Total seconds, 5 seconds. Now, but now if you run it again, first of all, the files are in memory. Secondly, there's no string to replace. So it becomes 0 seconds. Okay, so but anyway, we successfully did timing of the Emacs Lisp find replace. Okay, so today's talk show we successfully did the timing of Emacs Lisp find replace, and the code is here. Oh, actually, we need to modify more of these. Yeah, we need to, because okay, so we are almost done. Okay, so let's revisit the Emacs Lisp code. You see, we need to modify. Wait, did we? Oh, actually, this is not the right file. The right file is the here. Okay, open it. Wait, open it. What? Doesn't exist. What? exelisp.el. What? Wait. Copy the file path. Go here. Remove those. Paste here. What's the difference? Oh yeah, right. We changed the path. That's right. So open it, copy it, close it, and back to the Emacs Lisp. Okay, select all, replace it. Okay, this is our new code. So, and we actually need to do replace each one of these line by this block. Tedious. Let's see. Okay, let's do it then. Okay, let's just do it the idiotic way. So that replaced by that. Okay, next lambda by lamb okay, and number by num something. Okay, so this is our full code. Copy, put it back, and actually delete that because we don't want repetition. Open this, make a backup, select all, paste. Okay, so here is our full code. Let's double check one more time. Previous, type, lambda, num. Yeah, that's our full code. Save and backup and close. And we can now run this again. Remove all the directory, copy it, run and time the Emacs find replace command. 5 seconds, that's right. And run it again, 0 seconds. Oh, 1 second this time. Do it again. Okay, so this changes matters. Let's see. Oh, because each time, you see, each time that becomes that, but it still contains that. So there's more change to do. That's actually a good thing. Good test. That solved the problem I had before because of the loading files into memory. So okay, so the speed of this script is basically 1.7 seconds. Okay, it's Emacs Lisp. Okay, so we have done the Emacs Lisp code. Now you guys watching, okay, answer. What's the next language shall we do? Python or JavaScript or Golang or WolframLang? Pick one. Okay. Now you guys are here still, 8 people. Okay. Please tell me which one of the language we should do next, and maybe that's it for today. You know, I was hoping for Golang because Golang would be kind of most interesting. Golang would be faster. But for the others, I'm not sure. But anyway, pick one. Which one you are interested? Okay, so we're going to take a break. Be right back. 5 minutes. Mathematica, rat. Rat from you know, I know where you're from. But that's an interesting choice. So let's do Wolfram Language, okay? But I'm gonna take a break, 5 minutes. Okay, guys. So yeah, I'm gonna take a walk and smoke. Fantastic, okay? So next, yeah, fantastic. Smoke. Let's see how many. Let's see. That's good. So I'll be back in 5 minutes. I basically sit here all day and night and coding and do research on programming languages. Yeah. we'll be back. Okay, I'm back. And let's do Wolfram language then. Okay, Wolfram language, it's pretty simple. So I have already a script written. In fact, I have already written Golang, Python 3, Perl, find replace, and the regular expression version of Golang and Python. And here is WolframLang. It's already here, but it's you can find it on my website. Just search for Xiao Li Wolfram Language tutorial. Then you go all the way down. You'll find a Wolfram script. Here, script to find replace text in a directory. So here is how you do it in Wolfram Language. And you can find my Golang script for find replace. It's here. It's all linked at the bottom. Each script have different features, such as whether you want to write to file, and whether you want to make a backup, and regular expression for the file path, and whether backup or write to file, and what's a backup file name. So each one have different features. So here's Golang, here is Python. Okay, so I wrote all these in past 20 years. Then there is Perl. The Perl is my earliest one, 20 years ago, in 2000, around year 2000. Year 2000. So here's a Perl script. It has more features, Perl script. So then there's Emacs. Okay, here this one is how to do it in Emacs without using my find script. So you can do this interactively, but anyhow, we have showed how do you write it in Emacs Lisp as a script. So here's my package find replace in pure Emacs Lisp and using Emacs regular expression, not the Unix grep regular expression, because they are different. And here's a video I did before. So then so now let's go to Wolfram script. Okay, I already have it here. So copy this, close it. Now go to the directory, go to XX, new buffer, paste, and save this as X WolframLang. Okay. WolframLang .wl. Okay, save it. There it is. It shouldn't be here, it should be one directory up. So so let's move it. There it is. Open it. Fantastic. Okay, close this. Okay, so find replace. Now we need to modify the input directory and make backups so that we don't so that they are like kind of the same, doing the same thing. Okay, so input directory, it will be that. Make backup, we want to remove that. Okay, remove that. The depth infinity, actually the depth should be just 1. File name extension that. Okay, so let's modify this Wolfram script. Okay, so input make backup. We don't want make a backup, so we want to remove it. We want to remove it because what? We want to remove it because otherwise the checking will make it slower. So if backup is true, something, delete that, we don't care. So delete that. Okay, the depth is going to be 1. Okay, so let's look at the documentation for scan. Scan in Wolfram language is like JavaScript's for each, and Emacs Lisp map C. Okay, they are the same thing. Turn on JavaScript. And level spec, let's see what is the syntax. Yeah, so level 1 through n, level n only. So yeah, so that is correct. So the depth we don't need anymore. File name extension we need, and let's hard code it. Okay. Here you can use a glob pattern instead of regular expression. Okay, let's double check the code. Find replace pairs. Okay, here is already a list, so we copy the pairs we want to find replace. Okay, so there are 4 pairs there. Okay, so 1, 2, 3, 4. Right. Okay, the first one is previous, change it to that. Okay, that, change it to that. Lambda, change it to that. Number, change it to that. Okay, so that's the pairs. Okay, and process file is a function, takes module is local variables like Lisp's let. Comments. Okay, comments. So content read string. Okay, so content happened only one time, so content here can be just inline, so we don't even need that. And here is a write string. Okay, this is wrong. I mean, it's not wrong, but it's inefficient because even if there's no replacement, you are still writing to file. You don't want to do that because writing to file is very, very slow. Okay, so God. So if we want to fix it, that's gonna be, we do string replace here. We want to know if it's true or false. Yeah, in Wolfram language, it's gonna be super slow. It's gonna be much slower. Okay, but also read string file path that returns the file content as a string. Then you call string replace, and here's the find replace pairs. Okay, so hold on a second. The back here, this part is what is this? Date string now. That's now date. That's basically backup. Yeah, that's the backup. We are adding a date. We don't want that. So this part can be just that. We don't need block. Block is like a local. Declare local constants. I mean, well, no. Declare local dynamic variables. We don't need that, okay? Okay, so the code is actually just this. Okay, so module actually you don't need. The code is just like that. You see, in Wolfram language, it's much simpler. But there's an efficiency problem now. So when you do find replace, if there is a change, you must record it. If there's a change, you write to file. If there's no change, don't write to file. But it will be hard to code this and in an efficient way, because like, how do you tell if the file contains a string? You can create a variable. If you found a string, then you do the replace. If you found a string, record it that there's a string found, then you do find replace, then you save the file. However, if you do that, you see, when you check if the string is already there, that takes some time. Then you do the replacement. Basically, you are repeating the process, so that's inefficient. So you want a way to not repeat the process. And I do not know how to do that. Let's look up because the string replace simply return a new string. It does not tell you, it does not tell you whether there is actually some change. Let's see. Replace a string expression S by SP whenever it appears in string. Yeah. So it doesn't tell you it actually did the replacement or not. I mean, it occurred or not. So yeah, so in Wolfram language, this is just going to be super slow. But let's do it. Okay, let's just, yeah, so it's no point. Wolfram language is a loser here in terms of speed. But in terms of the time it takes to code is minimal. Okay, it's just, it's one single line. You can put this function in here, so it's just one single line. It takes 1 minute to code this, but compared to all the other languages, it's more slow. Okay, so actually this will do. So scan. So for each file name, something HTML in the input directory first level, you apply the function process file to all of them. Okay, so that's the Wolfram script. Now let's run the Wolfram script. Okay, so copy the file path. Copy the file path, close it, and close the Emacs Lisp, close that, and we want to run the Wolfram language script, which is so here's the script, and let's run it. So to run it, you do this. So Wolfram. Okay, so you need to run that Wolfram script. Actually, let's pop this out so we can easily see the PowerShell syntax. So Wolfram script, and here is the script, and that's not the right syntax. So how do you run Wolfram script? So let's go to my Wolfram language tutorial. Okay, and at the bottom there is how do you run Wolfram script. Okay, so you can either do it in code or file. So this is the way, dash file. Okay, close that, dash file. Okay, that should be it. Let's try it. Okay, let's hope all is good. Is that correct? Yeah, let's just run it. "7 seconds." let's see what was Emacs. Emacs was 5 seconds, you see. Emacs Lisp 5 seconds. Wolfram Language 7. Because there's an inefficiency, because it's trying to save every file. But now let's do it fresh, okay? Let's do it again. Now the second time is 1 second, much less than Emacs Lisp. I'm actually surprised. Wow. Now let's look at the directory. Let's see what did it actually change stuff. Let's open. Search for that. You see, it changed 3 times. You see that something something something. You see. So it worked. Okay, but now let's do fresh. Okay, let's remove all the directories. Copy it over. Okay. Close it, reopen, search for that. You see now it's it doesn't. For example, let's yeah. So you see, so now it's fresh. Close it, close it. Now let's run the Wolfram script. Do it. 1 second. What? Jesus! This is faster than Emacs Lisp. I cannot believe it. Let's open. Let's double check. No, something is wrong. Search for that. Okay, there is a bug, I think. Yeah, this Wolfram language, fuck it. Impressive, yeah, but there's a bug. Okay, no, there's something wrong. Run it. 1 second, but it doesn't change the file. You see, open it. You see that. If we go to, for example, let's look at what string we changed. That becomes that. These matching lines. It didn't change. So I think, so there's a bug. Actually, there's a serious bug in Wolfram language I have noticed before. Is that the bug is that once the Wolfram language reads a file, somehow it keeps the file in memory. So, when you are doing this read string, it actually doesn't read the file string, the file path fresh. It actually just uses whatever it's in memory. For some reason I haven't figured out. So so right now it's actually not doing anything because it considered the file is already whatever. Something is wrong. Yeah, okay, that's a failure in Wolfram language. That's pretty bad. Something is wrong. I cannot figure out. Maybe something is wrong. Somehow it keeps the files in memory. It shouldn't happen because each time we are running, Wolfram script fresh. So yeah, that's a problem. So and I won't be able to fix it right now because this happened to me before. I don't know. It will take me half an hour or an hour to find out exactly what's going on. Okay. Yeah, but but it's a very obvious bug. It's not actually changing files. We can run this code here. It says finished. But if you open this directory, open it, you see it's not changed. Open it, you see. So if we remove it, okay, let's see what happens. Now the directory is refresh empty. You see now the directory is empty. Now if you run the Wolfram script, it should return an error. Let's see what happens. You see, it doesn't return error. It kept the files in memory. This is a major bug. I'm gonna, I need to tell the Wolfram research people. Because last time I spent, at least 10 minutes, 20 minutes, I can't figure out what's going on. Okay, that's too bad. Wolfram is a failure, Wolfram script. Okay, so I think that's it for today. We should have, should we do another language? So let me know, and otherwise that's it. I think that's it. It's been 2 hours. Okay, so today at least we did the demo of the Emacs Lisp. Let's remove it. Okay, remove it. Okay, it's good. Let's copy it again. Copy it. And now let's run the Emacs. Should be 5 seconds. Emacs trustworthy. 6 seconds. Run a second time, it will be 2 seconds. Yeah. Joman says, when you run the Wolfram script, it has to launch the kernel every time. I thought so. That's what I haven't figured out. Maybe because if it relaunched the kernel, then obviously it should work. But somehow it's keeping things in memory. Apparently somehow it's keeping things in memory. That's why you have this cache issue. And the cache issue, it shouldn't happen because the code, we are actually reading the file. There's no, if you read the documentation for read string, you give it a file path, it returns the file content as a string. It does not mention anything about cache, but apparently it behaves as if it's reading a cache, so I have to look into. I don't know what's going on. It shouldn't, So so let's see the kernel. Is the kernel still running? It shouldn't. Okay, so do we have any? But the first test 7 seconds was valid. Yes. Yes, that is absolutely valid, and we verified it actually changed things. But you see, now it's a problem because how do you even get it to remove the cache? Because Wolfram kernel is not running. I don't think so. Is there a way to search tasks? This Microsoft idiotic process manager. If you look at by name, let's see details, users, startup, details. Yeah, so can you magnify this window? No. Fucking idiotic Microsoft. Microsoft Windows sucks in every way because you have this ease of access. This allows you to change globally your text size, but doesn't work in many of the applications. So here you look at Wolfram W. I don't see any Wolfram kernel process. However, if we run the Wolfram script, I think you will see it. Yeah, if we run it and look at over here, I think we should see Wolfram. Let's go here. Okay, run it. It's too fast. Well, let's try this again. Run it. Okay, we need to refresh faster. Update speed high. Okay. Order by CPU. Run it. And it's too fast. Run it. Let's put a timer here. Sleep. Is there a sleep? Is there a pause? Okay, let's see what is the documentation. Pause for at least n seconds. Let's say pause 5. That way we'll know. Okay, now back to the shell. Okay, where's the process manager? Okay. Now run it, you'll pause for 5 seconds so we can look at the Wolfram kernel. What the fuck? Okay, it paused, we can see. But let's pause for 10 seconds, 20 seconds, okay? Run it. What? There it is. There it is. You see, 2 of them. Wolfram.exe. That's a kernel. There it is. Now it's good. Okay. So you see, so Wolfram kernel was there. Now it's good. Now it's 21 seconds. That's correct because we delayed for 20 seconds. But so I think somehow Wolfram language, the kernel, saves a copy as a cache somewhere in a Wolfram engine directory. So we have to look into that. Let's run it again, okay? Run it. And let's see, CPU, memory. Fuck, you cannot enlarge this. Okay, this is not useless. Let's delay it to 60 seconds. Let's say 200 seconds, okay? Run it. And now we have time to look up Wolfram language here. Where the fuck is it? The font is too small for me. So do you guys see it? I don't see it. Now let's go to details. You see, in details you can see those two processes there. Process 18124. Okay, now let's go back to process. Now they don't show process number. Do I make sense, guys? Window processes 90. Okay, but Wolfram, where is Wolfram? Instead of default task manager, just use process exp. Yeah, but that requires download, right? I'm aware of that, but I was trying to avoid complexities. Okay, let's try it one more time. Oh, actually, this is still running. It's still running. Details, yeah, it's still there. Process 18124. But how do we show the process number? God, this is fucking PID. There. PID 18124. It doesn't show up here. Oh. What? So there's some new interesting discovery. That now it's done. You see, now it's done. Now you see, now you don't see it anymore. So, but let's try to change it to 5 minutes. 300. Run it. Okay, so you can see the process number here. Wolfram.exe 10424 and Wolfram script 13972. Okay, 10424. Now back to processes. PID 10424 104. It's not here. The Wolfram kernel process is not listed in the processes. 10492. Let's try. Let's check again. Details. 10424. Okay, 10424. So it's not showing up in the process. Fuck. You know? So now the Wolfram language complexity, now trying to debug it, now it becomes Windows complexity. Why is the process not showing this in this fucking idiotic Windows? Fuck. Now I haven't used the process. You see there, 12424. That's a Wolfram kernel process, but not showing up in the task manager. What the idiotic fuck. So apparently some processes you can hide it or something. And even the Wolfram script is not showing here. So what if we do something computational expensive? Should the CPU show up here? I don't know. So anyway, what happens if I run in a notebook? Okay, let's try that. Okay, so let's start notebook. And let's kill the Wolfram. Oh God, is it safe to kill? Now you see the Wolfram notebook shows up. Desktop kernel. And I'm pretty sure it show up here too. There you see the Wolfram desktop shows, but not when you do Wolfram script. What's the settings? Idiotic Windows. Okay, so let's open a new notebook. Okay, Wolfram notebook. First of all, we need to stop the. Okay, we canceled it. Let's see, make sure it's canceled. Yeah, Wolfram kernel, the old one is gone. Now it's we have the notebook desktop, Wolfram kernel.exe, and Wolfram kernel, two of them. Okay, let's close. Let's make sure we don't. I want to make sure everything is fresh. Okay. What? So Windows key. Let's start Wolfram notebook. Okay, so you can see when it starts, it launches two kernels. Now open a new notebook. Now type something, evaluate. Okay, you can see it still launches two kernels. Okay, so okay, now let's copy our code. Let's remove the pause. Okay, let's comment out the pause. Copy the whole, put it here. Okay, that's our code. And go back here. Let's clean up, remove the whole directory, copy it. Okay, now let's run. Let's put a timing. Okay, run it. What? 0, no, what? Zero seconds. What? Did it actually change anything? Search for that. It doesn't. You see, it didn't change anything. Run it again. Run it again. Okay, something wrong with the Wolfram script. Fuck. I don't. Yeah, it's the same thing. Same thing. I don't understand. It worked the first time, right? Did it? Let's change. Let's try to change something. Let's change the to all depth. Run it. It's instantaneous. Meanwhile, it didn't actually do anything. Close. Reopen these matching lines. That it didn't do anything. Okay. While the script is running, these processes are all attached to a window in a non-detailed view. Okay, you might be right. Okay, so you are saying the Wolfram process might be under PowerShell, maybe. You know, when we were running in PowerShell. So where is the PowerShell? Yeah, so before. Okay, let's try again. Okay, now let's This is very, oh, okay, here's a problem. That is a problem because you are using the tilde. That's one of the problem at least. Okay, let's fix it. So typically you want, in Wolfram language, it won't auto expand. Okay, so that's a script. So first of all, turn off, don't save, turn off quit Wolfram language completely. Okay, now let's see the PowerShell. Okay, now let's watch the PowerShell part, see if the Wolfram kernel shows up there. Okay, now first of all, remove everything, recopy the directory. Now run this Wolfram script. Okay, run it. Okay, let's see. There it is. Okay, it showed up in PowerShell. Do you see? Fantastic. 6 seconds. Okay, let's run it again. Do it. 3 seconds. Let's run it again. It should be 3 seconds. Fantastic. So now let's open the file to double check if it actually changed things. Open it. Yes, it changed, except that it got this end of line screwed up. Let's list matching lines. That, you see? So it worked. Okay, so in Emacs it was 5 seconds the first time. So Wolfram language is 6 seconds. So every subsequent time you run it, it's 3 seconds. Okay, every subsequent time you run it, it's 3 seconds. Wolfram language works. Now let's try again Emacs. Remove everything, copy it, run Emacs. Emacs script the first time is 6 seconds. Okay, subsequent run is 2 seconds. Okay, run again, 2 seconds. Okay, now let's do it over again with Wolfram language. Remove everything, copy it, Wolfram language, (6 seconds). Same thing as Emacs. Okay, now subsequent run, (3 seconds), much slower than Emacs. Yeah, the reason is that because that's not the flaw of Wolfram language. Well, I mean, the reason it's slower for subsequent run is because we didn't check what's changed. So it's actually saving every file it opens. It resaves them, and that is a huge cost, making it slow. So anyway, so that's it for today. We made some progress about this issue about which language is fast. So what we need to do next is to for example, fix the Wolfram code so that it will only save the file when there is a change. Okay, I don't know how to do it efficiently. Because if you check it, then you are basically trying to find the string again. So I don't know how to do it efficiently in Wolfram language. But while in Emacs Lisp it's easy, what about in Golang? Oh, okay. So in Emacs Lisp, the way we do it is that we just, we first of all, we do a search on each of the find string. If that occurs, then we mark it, it's changed. So we can do the same thing in Wolfram language. We can do the same thing in Wolfram language by instead of calling replace string, we just say search string. Find the first occurrence. So if it's found, then we call the replace string. Yeah, that can work. So if we do that, then the Wolfram language will be comparable. I mean, our code will be comparable to the Emacs Lisp version. Then we can properly do the timing again. And one more thing. For the timing, I think we should, instead of 1,000 files, we should concatenate all these files into one single file. So that way we can focus on the speed of find and replace string, and write out one single file instead of getting distracted by the time for writing each file and the time for parsing the directory. Yeah, and if we do that, then I think Emacs Lisp has a chance to be faster than all these other languages because of the Emacs buffer data type. Okay, that's it. Thank you guys for watching. The time reduction is because the cache memory all the time launching a kernel. Oh, the time reduction is not because of any of that. It happens in Emacs Lisp too. The time reduction happens is because we are doing these 4 replacements. Doesn't matter which language. You see, so the first time you run it, you have 4 pairs to replace. But once you do that, you no longer have the string previous. You no longer have the string lambda. You no longer have the string number. But only this string, that becomes that something. So that's why there's a time reduction. Okay, and there's another issue, that is the time to read the file, because that is a huge, because I do find replace on thousands of files almost every day, for the past 20 years. And the biggest time, the bottleneck in time is loading the file. So if you do, grep, it's same thing for the grep, especially for grep. If you do grep for the first time, it might take 30 seconds. But the second time, it's, 1 second or something, because all the files are in memory. So anyway, to summary, to do this again next time, is that we need to fix the Wolfram code so that it will only save the file when there's a change, and the algorithm will be basically the same we did with the Emacs Lisp. Okay. Then after that is done, then we need to concatenate all these files into one single giant file. Maybe 3 mega, 5 megabytes. One huge file. Then we do the comparison. Okay, so that's next time. Thank you guys for watching. Bye guys. Okay, if you like my stuff, if you enjoyed my show, pay me. Okay, PayPal, Amazon gift card, or you can buy my Emacs Lisp tutorial or JavaScript tutorial. Okay, bye guys. Long time no see, Rat. We should do some video chat. Join Discord and join Kasa Discord. Sometimes we do a voice party. So